All right, so today we're going to review 6.1 and 6.2. And then at the end of class, I'm going to talk about lab 5. We're going to skip lab 4. You guys are aware of that, right? Project part 4, we're skipping that one.
We are?
Yes. And then lab 5 will be due, I think it's I think I'm going to have it officially due the day after the exam. Right, so that for you guys that'd be the 17th, I think. Okay. All right, so today we're going to go over, after that we're going to go through central limit theorem. We probably will not do normal approximation to the binomial. I'll go over that next class since it's not on your exam. The exam is only going to cover up through 6.3. Due today you have 6.1, connect math. Sunday, you have homework due on Sunday, 6.2. Please do this. When you're doing the homework, here's the deal. If you look at the help buttons, don't do the help buttons, because the help buttons want you to use a Z table. You can just use normal CDF like we did in class. But the table only uses 2 decimal places for Z-scores and 4 decimal places for areas. So if you use more than 2 for this, then you're going to get the wrong answer, and you'll be like, what's going on? And you'll have no idea why you got the wrong answer. Do you guys understand what I'm saying? So just use 2 decimal places for your Z-scores, and then just use round this to 4 decimal places. So round to 2 for Z's, round to 4 for areas. It's written in the title of the actual homework assignment, so you guys can remember to do that. Because like I said, otherwise you'll mark it wrong, and you'll be trying to figure out why. And it's because it's assuming you're using a table, which is rounded to those things. Okay, good. So Sunday 6.2 is due. Tuesday 6.3 is due because our exam is a week from today, on Thursday. Good. I'll do a review session on Wednesday, the 11th, from 6:30 to 8 in 601. Or 600. Quick notes about the exam. It covers chapters 3, 5, and 6, but not 6.4. You're allowed 1/2 page, one-sided of notes, handwritten by you. And again, you're going to have 2 parts. You're going to have a part where you use a basic calculator, a real simple basic calculator that can only add, subtract, multiply, divide, maybe square root. Who has one of those?
The basic calculator?
Yes. Who does not have one of those? So either you have to have one or not have one. It's an either or. It's a binomial, right? It's either. All right, so I think I have enough for you guys who raised your hands. If you didn't raise your hand, then you are not necessarily going to get one from me. Okay. All right. All right, and don't forget your extra credit opportunities. Quiz problem number 1. Take 10 seconds with your neighbors and discuss this and see if you can come up with those 4 terms that can be used interchangeably. Rosa? Armida Rosa? Ashley, slide over and chat with Adam. Adam, pull Ashley in with you guys. All right, so let's take a look. Let's get a reader. Gina, go ahead and read the top part.
To summarize one point, area under the curve equals probability equals percent of population.
Perfect. So here is my curve. This is the area underneath. So between these 2 values, this is the area underneath that curve, right? So that area under the curve between these 2 points, between these 2 values, is the same thing as the probability of someone being between these 2 values, which is the same thing as the percent of population that lies between these 2 values. Those all represent the same thing. What is, if you add up all the area under the curve, what do I get? 1, good. If I add up all the probabilities in a distribution, what do I get? 100% or 1? 100%, which is 1. If I add up all the population, what percent of the population will I have if I take the whole population? All the population would be what percent of the population? 100%. Those all add up to 100% or 1. So now with your neighbors, figure out what, that's 3 of them, figure out what the 4th one is. Go ahead and talk, find it.
You said that there's 3 of them.
Remind me, Neil, who the answer is.
Okay. Bye. Bye.
All right, what's one of them? Someone give me one of them.
Probability. Me.
Okay, so again, to summarize 1 point, what equals what equals what?
Oh, area, probability.
Yeah, so what's 1?
Area.
Area.
That's messed up.
Probability,
Percent of population.
percent of population,
Related frequency.
relative frequency.
Relative.
Right, because remember, relative frequencies are the percent of the population that's in that category. Do you guys remember that? Yes?
Check it.
Those are all related. Okay. Austin, go ahead and read.
How to use the calculator to find the area under the curve, percent of population. Normal CDF gives you the area between 2 z-scores. Press second bars, then choose distribution and down to normal
Number-
CDF, which gives you normal CDF.
And then you put in your left z-score, or I should say your lower z-score, comma, your upper z-score. And that will give you the area between them. Right, so in this example, this is my lower z-score, this is my upper z-score. It's going to give the area between them. So either I'm going to give you 2 values, and you need to find those z-scores and find the area between those 2 z-scores. So if I give you 2 values, 2 z-scores, you find the area between those 2 z-scores. If I only give you 1 value, or 1 z-score, then it means that you're going to have to find the area, there's somewhere along the line they're going to ask you to find the area below it or above it. Make sense? So either less than it or greater than it. Which means the other one, if I do, here's my z-score, is this going to be less than or greater than, guys? Less than. So that means that my other z-score is going to be way out here. What's it going to be? Negative infinity. Good. How about this way? This one down here. Here's my z-score. What's his area? Is it greater than or less than? Greater than. So it's going to be, all the other ones going to be way out here. What's it going to be? Positive infinity. Make sense? So then you'd go lower to there, or lower one out to infinity. So either I give you, like I said, either I give you 2 z-scores, and you find the area between them, or I give you 1 z-score, and you find the area below it or above it, using normal CDF. Because normal CDF, you always have to feed it 2 things. Either you feed it the 2 z-scores, or you feed it this z-score to infinity, or that z-score to negative infinity. All right, so this was your, you had here. This, for the exam, this is how you need to draw this. First thing you're going to do is draw a picture. What are you going to draw? A hill with the ground, and then put just a notch only where the middle is. Do not do this. Why? Because when people do this in the middle, then they start stopping here or starting here, and they make this a starting or stopping point, and that screws everything up, because it usually isn't. Yes?
Can you write 0 under it?
You can write 0 under it if you want to.
Okay, cool.
Yeah, but just don't draw a line up. Then, you find the one you care about. What's the one we care about at this point? 0.75. Is it on the right or the left? Right, so we're going to put in 0.75, and then this one we go all the way up. Am I going to shade to the right or the left? So here, again, don't forget your Nemo. Right? Z is bigger. The bigger one's harder to catch, so you want to shade to the right, because you want to shade to the step that is Z is bigger than 75. So over here. And then this is going to go out to positive infinity. Good? Then you're just going to do, what's the next thing we do then? Normal CDF. 0.75, comma, any large number?
87.
87. Great. Any large number. Sad spelling. Large number. Okay, good. Applications. So every single value, every single x value we have out there, in your case it was calories, every single value has a z-score. What's a z-score again? Number of standard deviations it is away from the mean, how far it is, how many standard deviations it is from the mean. So every value you can figure out how far it is from the mean and how many standard deviations that is. Right? How far it is from the mean, what is that in standard deviations? Divided by standard deviation. So every single x value will have a z-score. One x value has one z-score. So with an application, you're going to, very rarely do we say, oh, I want to know the probability of having a z-score between blank and blank. We want to say, well, I want to know the probability of an entree costing me between $3.50 and $4.50, right? It's all about stuff. So I'd have to find the z-score for $3.50, find the z-score for $4.50, and then normal CDF of those two z-scores. So all application does is, first thing you do is find the z-score for every value you're interested in, and then do the thing we've been doing. Draw your picture, put in the z-scores, shade, and do normal CDF. So again, these are the steps. First, convert your data values to z-scores. This is at the bottom of page 4, I think. If you did not fill it in, you should fill it in now. Bottom of page 4. Convert data values to z-scores. And then, Justin, you're filling these in at the bottom of page 4, right? Number 2, draw a picture. Number 3, use normal CDF to find the area between the two z-scores. Everybody has those in?
Yes.
Okay, great. Here is kind of a drawing of how that might go. So first, your first step is convert your x to z-scores. Your second step is going to be drawing a picture. And then your third step is going to be using normal CDF to find that area. Here was the example we did, and I hate the fact that they drew this picture with all these things in there. Right, so just to point out what I hate, I think you definitely do not want to line all the way up there. I think it's distracting and confusing. I also think that maybe you don't even need to put the x values in there. Maybe it's easier if you stick with z-scores in there. It's up to you. You can put both if you want. But I think sometimes that might be a little bit confusing for folks. So first, adult has an average 5.2 liters of blood. What's 5.2? It's my average. Average is what? Mean. That's my mu. Normal distributed, standard deviation of 0.3. What's that? It's my standard deviation. Sigma, good. Find the percentage of people who have less than 5.4 liters of blood. What is this? gets my x value, right? And I'm trying to find, I want to find less than that. So I need to find the z-score for that x value. How far is 5.24 from the mean? And then divide by standard deviation to get that in standard deviations. It is 0.67 standard deviations above the mean, because this is positive. Then I will draw a picture. Draw my little hill, draw the thing across the bottom, put just a tiny tick mark in the middle for my mean. That's it. Then, where does 0.67 go? On the left or the right? Right. Draw a line up. And I want, what do I want? Less than. So is that the left or the right? Left. Good. So we're going to shade over there. So that means if I'm going to go all the way up to the left, I'm going to have a little z-score way out here, which is going to be negative infinity. What is the next thing and last, what's kind of the last thing I do? What's that? Normal CDF of any large number, would you say? 169, sure. Comma, 0.67, what'd you guys get? Oh, sorry, negative, sorry. Any large number? What do you guys get? Anyone? No one's gotten this? Oh, sorry, this is not your problem. My bad. My bad. That was the example. So who cares what you get? This is your problem. Chocolate bar calories. So, again, you're going to find the z-scores for 200 and 220. Each one of them has its own z-score. So find the z-score for 200. How far is it from the mean? How many standard deviations is that? Find the z-score for 220. Then, draw your picture, find the probability that x is between those two values, explain what that means in part C. So I'll go ahead and give you guys 5 minutes to work on that. Seem okay?